Good morning, everyone, or afternoon, whatever it is when this gets presented. My name is Mike Powell. I'd like to thank Eric for the chance to address the AGM. I'd like to talk to you about the Elmvale Groundwater study, the past 3 decades of why we're here, what's happened in the present, which we'll consider from 2019 to 2023, and then what the future holds for this project that we're planning. By way of introduction, I think it's important that everybody knows who the players are in this project. We have a science team made up of 3 universities, some of the top people in Canada in their fields. We also have a group of partners, which is growing steadily. These partners are important because they will not only take an active role in the project, they will provide objectives from their own organizations and help us design the study in such a way that the results of this study will benefit them. And with the science team and the partners working together, we hope to be able to improve the ability of Canada to manage resources and to improve the quality of life of people in Canada. We know that we're meeting because of our care for the environment. Simcoe County has some of the most amazing groundwater ever described, pristine, according to the last 30 years of research. We also know that anthropogenic and natural forcing impacts groundwater. We certainly know that hydrogeology disruption will decrease quality and quantity of water. We know that the uplands in the area of the study area are important for providing water to the lowlands where the water bubbles up out of the ground. We know that artesian flows do not all necessarily have the same source. And we know that if we disrupt hydrogeology, we have a possibility of destroying the water. The important thing in this slide is that there is no one yet who knows the answers to these questions. No one has done the proper type of study to be able to answer whether or how much each of these variables is being impacted. That's the goal of this study. I think it's important to start at the beginning. In the upper left part of this slide is the Laurentian Valley. That valley between the Niagara Escarpment and the oldest rocks known in Canada to the northeast was dug out by glaciers many times over the history of the earth. Each time a glacier came down, it eroded deep valleys, as shown in the lower left part of this slide. And when it retreated, it filled those valleys with a very complex set of sediments. And those sediments are what we're dealing with. The lower right part of the slide, the red square, shows the approximate area of the field study that we'll be doing. The light green areas are the plains and or river valleys that occur in between the colored upland or highland areas, which are yellowish to red and reddish brown. These are the major recharge areas of most of the aquifers in the clay plain environments. And this is the hydrogeology that we will study. When those glaciers retreated, they didn't leave a nice clean stack of rocks like we see in a lot of sedimentary rocks. As you can see in this upper graphic, the toe of the glacier that comes down is riddled with rivers and distributary areas, kettles, small lakes, all superimposed on the tills and the older tills that have been laid down in the past. When all of this ice is gone, that stack of sediments that sits there is very complicated. In the lower diagram, you can see large areas to the right and to the left that have been eroded away after the lower sediments were deposited. So that when these individual black vertical lines representing cores or wells are put down, we find very different stacks of sediments over very short spatial areas. And this means that it's extremely difficult to be able to unravel the hydrogeology and the geochemistry of these areas. That's part of the job of So let me just quickly boil down the whole glacial history and the present sedimentary situation and hydrologic situation in the area. If you look here, you see the Georgian Bay to the west, the clay plain directly associated with it. Then you see the slope where the uplands are located with river valleys in between. We have three sources of water in this area. One is the precipitation of ice or snow, or rain and snow, and that carries human fingerprints from absolutely anything we do, whether it be transportation to industrial activities, agriculture, or just windblown rock and soil dust. That water hits the ground, filters down into the soil. At the bottom, then, we also show that we have bedrock bubbling up through the glacial sediments of the area. That's water from some of the oldest rocks in Canada. We do know that it happens. Then to the east, you see the slanted line in the middle, the aquifer. Water that lands to the east has easy access, as it does all the way along, into the aquifer that travels down through and that we pump out of the ground. So we have current precipitation, we have ancient water trapped in glacial sediments, and we have bedrock sources. The question is, how important are all of these different sources to the final water that we find in the clay plain, the pristine waters that we know so well? The field area for the study is going to be just to the left of the upland area here, the last uplands and the clay plain to the west. The groups of 2 stars each that you see on this map show areas where we're either placed lysimeters in 2022 or where we will place them in 2023. And I'll show you some results of those placements in just a minute. Again, those lysimeters are placed there to collect soil water so that we can see differences in different areas. The lysimeters themselves are objects, as you can see on the left-hand side of the screen here. It's effectively a tube that we put down in the soil with tubing inside of it so we can sample water from the different depths that we put in. We will have 1, 2, 3 different depths of lysimeters at each site so that we can look at the water in the bottom of each one and see how the groundwater is evolving. So from the precipitation into the soil, we can look at microbial or mineralogical differences and changes, difference in hydrogeology, all of the parameters that will change the composition of groundwater as it flows through a soil. The main thing we're interested in is how well the soil column, is able to filter out material that enters the ground from precipitation. So those lysimeters that we just talked about, put in 2022 and the early part of 2023, are being sampled for water now, or the ones from 2022 are. The next stage is for the University of Guelph to put in the infrastructure for the larger groundwater project. And this will be done at 3 to 4 different places where we will put on the highlands, on the terraces, and in the clay plain, numerous holes, both cord holes and piezometers. The cord holes will go from the surface to bedrock. Those cores will be brought to the surface. They will be sampled, and those samples will be sent to different universities for different analyses. Through this, the University of Guelph will be able to put together the hydrogeology of the area. University of Ottawa will be able to do the isotope geochemistry, age, origin, mixing, and the University of Alberta will be able to look at major and trace element compositions and geochemical processes that are going on to impact the water as it evolves, as it travels along the hydrologic pathways. I'm showing you this slide because I've had people suggest that the groundwater project is way far behind in happening. I want everybody to know that the groundwater project has been evolving since 2019. And I want to give you 3 examples because these examples fly in the face of reports that have been done about this area. First, you may have heard that there's no water in French's Hill. You look at the upper left-hand pictures here of the waters flowing along the terraces and open water standing in the well at the top of French's Hill. I'm telling you that there is water in French's Hill. This picture up here of the stream is water running out of the base of French's Hill onto the terrace. The well itself is located right at the top of French's Hill. We know that there's water there. We've also analyzed wells from around Ore Lake and from other areas, and we know from the isotope geochemistry, that graph that you see there in the middle, that these waters are from the surrounding moraines. They are from the uplands, and we know that they're not Pleistocene in age, meaning they're much younger. This also contradicts what's been said by other people, that in fact the moraines, the uplands of this area, do not supply water to the aquifers of importance. We now have scientific information and data that says it does. And that lower graph is or table is just one of the few tables that we have for major and trace element analysis. There has been a tremendous amount of analytical work done on the sediments and the waters that we collected in the area. We're compiling all that information, and it's helping us to plan the larger groundwater study. The bottom line is there are differences from the different aquifers and the different geologic formations that we get this water from, and it's important we know what that difference is in order to understand the evolution of the groundwater. Let me just try to bring this all together with a timeline to ensure everybody in this meeting that the process has never stopped since Bill Shattuck started over 3 decades ago being curious about this water. The process of understanding this water has never stopped. It intensified in 2019 when we had our first science meeting and our first stakeholder engagement meeting in Elmvale, both very successful. At that time, we began the process of trying to write a very complicated project for funding by the Natural Science Engineering Research Council. In 2020-2021, we decided to submit an application to the Alliance Grants Option 1 of NSERC, but that requires a 33-66 funding sharing. So we had to raise 33% of the money. COVID came along and disrupted a lot of our activities. University laboratories shut down, personnel not on campus, et cetera, et cetera. But we kept sampling the water, and we kept doing field-related observations about the aquifers and where the water comes from, et cetera. In 2022, we used the previous information in order to install the first set of lysimeters. Were installed and sampled in 2022. The data from those samples is now available. And we got a bit of a windfall, and that is that NSERC changed its funding platform in such a way that we could apply for an alliance grant and they would provide 100% of the funding. But the limit is $5 million, which is lower than in the previous option 1. But we found out that we could, by discussion, meet our obligations with lower money if we had to. In 2023, we can say that the total $5 million budget is complete. The second set of lysimeter-free lysimeters designed at University of Alberta will be placed in the soil. Sampling of the 2022 and 2023 lysimeters will go on this summer, and we will hopefully finalize and submit the grant application. Let me reiterate, the whole purpose of this slide is to show that the progress or the seriousness of the applicants and the proponents for this project has never faltered, and the progress has never stopped since it began 30 years ago, in particular, since we got together and got serious about submitting this proposal in 2019. Again, thanks very much for having me on. I'm sorry if some of that was a little rough, but I've never done this talking head thing in a PowerPoint presentation. I think I cut myself off some. I've had to do this numerous times. It's never come out exactly right, so there's a time to quit. Please don't hesitate to get in touch with me at any time to discuss any of this in further detail. It's been a pleasure being with you. Good luck with your meeting, and I'm sure I'll see some of you in the future. Take care. Call me anytime. Write me email anytime.